Problem 2. Determine the maximum spacings of the nominal 2 by 4 inch lateral braces. So this is brace or strut. For the goal form of problem 1, place as shown in the figure. Assume that the local code wind requirements are less stringent than table 13.3. And allowable stress value for the braces are as follows. They give us allowable stress in compressions, allowable stress in tension, and elastic modulus of elasticity of the brace. And from the figure shown, and with the equation that we learned for design for lateral bracings in the previous video, with the H lateral load at the top of the form, the height of the form H small, S apostrophe, height of the top of strut, L the length of strut, L apostrophe horizontal distance from form to the bottom of strut. So from here we can determine the yes 5 feet it actually L apostrophe, 6 feet is the H apostrophe, and 8 feet is H small. Then we can start design, determine the maximum spacing. So what are the maximum between the space for the braces or the strut as shown there. So first we need to design the lateral force per unit length of the form. Design lateral force per unit length of form, and that from equation that we have H equal to P apostrophe and also H, and S is the lateral load from the top of the form. So what is the lateral load here? Before we determine, we need to P apostrophe, we need to know H and on other dimensions, and the on other dimension I already show that in on the finger. And then now what we need is to determine the H capital, which is the lateral load at the top of the form, and that we can go to table 13.3 with the height of the goal here is 8 feet. So we go to the final exam reference. This is the on page 3 we have table 13.3, and in the middle row we have 8 feet for the goal height all over, but less than 22 feet. The H, the lateral force, is 100 pound per foot. So that one we can go back here to see that H equal to 100 pound per foot, and that from table 13.3 and available in exam reference. And then we can determine the length of the strut. And for the length of strut, we know the lateral, the vertical length H apostrophe, horizontal distance L apostrophe. So the L equal to square root of H apostrophe square L apostrophe square, and we have that equal to 6 square plus 5 square, and that one equal to 8.71 feet. So when we have all of that, we can determine the actual concentrated load. Actual concentrated load, and that is P apostrophe, and from the equation just shown, H times L over H apostrophe L apostrophe. Plug on the number we have 100 pound per foot. H, the height of the goal, 8 feet. L, just determine 7.81. S apostrophe 6, L apostrophe 5, and from that one we have 208.3 pound per foot of fall. So that is the P apostrophe. And now we need to consider the deflection as I shown here in the for consider buckling, and we need to find out the ratio of the member length to the least dimensions of the members. So L over D. So what is L over D? We have to determine L over D ratio. So how can we have? So the members of the brace is 2 by 4 inch. So you have 2 by 4 inch. Then the actual, it will be 1.5 times 3.5 inch. This is the actual dimension, and that is nominal. Where we can get that? Remember we did that in previous lesson, and go to the table on page 7. So it's 2 by 4, the actual size 1.5 by 2.5. Then we can get back here. From there we can get the ratio here equal to L 781. D, what is D? Is the least dimension. So between 1.5 and 3.5 of cross section, 1.5 is the least dimension, 1.5 inches. So we divide 1.5 divide by 12 to make the adjustment for the unit conversion to feet. There we can get 62.5. And at the previous lesson, this ratio have to be, it's not too slender, have to be less than 50. If more than 50 is too slender, and if you learn in mechanics of material, the member is too planar, it's easy to buckle. So with that, it have to be less than 50. But this one is more than 50. More than 50. How can we do? So basically too slender. How can? We can provide, assume we can provide the lateral support somewhere here in the middle, so that we can have the lateral support to reduce the length, effective length of the brace. So this is the lateral support. So with that in the middle, so we can, from that it's not good, this is greater than 50, not good, then we provide lateral support. At the midpoint of each strut or brace. Each strut. Then what do we have? Then we have the new L equal to 7.81 divided by 2. We'll put in the mid, so we divide to get the new effective length, and that is 3.905 feet. And then we can have new L over D ratio, 3.905 divided by 1.5 over 12 equal to 31.2, and that less than 50. It's good. So the ratio now is not too slender. So okay, then we can go ahead to find out the allowable unit stress in compression parallel to crane adjusted for the L over D ratio, FC apostrophe. So that equation you can plug in here. We have FC apostrophe equal to 0.3 modulus of elasticity divided by L over D square. So we have 0.3. The problem gives us for the material E 1.4 10 power 6 power per square inch. Plug in 1.4 10 power 6 divided by L over D square. So 31.2 square. Then we get 431 power per square inch PSI. So when we compare, what they given us is the FC 850 pounds. So that is the allowable stress in compressions, and then allowable stress in tension 725 pounds per square inch. And GC allowable stress, consider the deflection is 431 psi, so that you can see that as FC apostrophe, the allowable stress that consider compressions determined in here, that adjusted for L over D ratio is mean consider buckling, and that is 431 psi. It's less than FT 725 given, less than FC 850 psi given. So you can see that the buckling is governed, so it FC apostrophe governed. So when it governed, we can go ahead to determine the maximum allowable compressive force per strut. Force per strut or brace, and that P, and P equal to the areas times FC, right? You have the areas of cross section times FC apostrophe. Area of this cross section is 1.5, 3.5, because that is 2.4, 2 by 4 for that brace. So the actual dimension is 1.5 by 3.5, and then FC apostrophe 431. So you have 2260 pounds. And when you have that, we can be able to determine the maximum strut bracing spacing. Maximum stress spacing by going to the equation we discussed in the previous lesson video, that is total load per strut P equal to P apostrophe strut spacing. Now we already know P, we know P apostrophe, so we can determine strut spacing from that equation. So maximum strut spacing is equal to S equal to P over P apostrophe, plug in P 2260, P apostrophe. We already determined earlier actual concentrated load per pound 208.3 pound per foot of form. So 208 208.3, then we can have 10.8 foot, and that will be the answer for this problem.